In this video, I would like to give you the reason, or well, a reason, why in the kinetic energy formula that we square the velocity. I'm going to give you just a simple mathematical reason. There are better reasons based on actual evidence, but I'm not going to go into that. I'm going to give you a simple mathematical reason. Okay, so on the one hand we have momentum, which is mass times velocity, and on the other hand we have kinetic energy, which is 1/2 times mass times velocity squared. They both have mv in common. The only difference is over here it's the velocity squared. Now, what's the big difference between the both of them? Well, momentum is a vector and kinetic energy is a scalar, which means that when it is a vector, the direction matters, and when it is a scalar, the direction is irrelevant. So when we have mass times velocity, we have mass, and now mass itself is a scalar, which means it doesn't matter in which direction an object is going, the mass of the object is always going to be the same. All right, so if an object weighs, I don't know, 2 kilograms, and it's going to the right, to the left, or to the north, to the south, whatever, the mass is always going to be the same, and it's always going to be a positive value, right? Mass is always positive. Mass can never be negative. That's impossible. So that's why it's a scalar. It's always going to be positive. That's what it means when direction does not matter. Okay? Right, now velocity, on the other hand, is in fact a vector, which means that the value of it depends on which direction an object is going. An object can actually go in multiple directions with multiple velocities at the same time, and so it will have a net velocity in a net direction. When you add those multiple directions and multiple velocities, when you add those together, then you will calculate your net velocity in your net direction. So an example, we're going to use a very simple one-dimensional example. Let's say you have a person, right, and he's sitting on a train or standing on a train, on a wagon, and let's say you have multiple wagons, right, and the train is moving to the east side, right, to the east or to the right, with a velocity of, let's say, 20 meters per second. Now the person in the train is moving to the left. He's walking to the left with, I don't know, let's say, so to the west with a velocity of 5 meters per second. So what's going to happen is we have two velocities, and the person is going to have a net velocity. So what will that be? Well, we'll go to the east eventually. The net direction is to the east with a velocity of 15 meters per second. So how did we calculate that? We had to do 20 minus 5, which is 15. We actually had to subtract. Now, in physics, we do not use east or west side. We use positive and negative signs. So we can replace the east for, I don't know, positive sign, and the west or the left side with negative sign, minus sign. And then the only thing we have to do is we always have to add them. When we use negative and positive signs for the directions, for the left and the right side, then the only thing we have to do is we have to add those values together. That's called vector addition. Now we always have to add them. So now we have so positive 20 meters per second, right, plus a negative 5 meters per second, sorry, like this, negative 5 meters per second, and that equals plus positive plus negative positive 15 meters per second. Now the positive only indicates that it's going to the right side, in this case, positive 15 meters per second. Now you can also change these signs. You can also use the minus sign for the right side, and we can use the positive sign for the left side. When we do that, then we have negative 20 meters per second, right, plus positive 5 meters per second, and that will equal negative minus 15 meters per second. So now you might wonder, wait, a negative velocity, how is that possible? Well, no, of course, it's not actually a negative velocity. Nothing can have a negative velocity. It only indicates the direction. The minus sign or the positive sign only indicates the direction, right? It's just that when we actually use the positive and the negative sign for the directions, for the left and the right side, then the only thing we have to do is we always just simply have to add those values. And that will give you the net velocity, the net direction, right? And the negative simply means left side or positive right side. Or you can swap them around and such that the negative means right side and the positive left side. You know, you can choose. You can choose for which side you use the positive or the negative. I mean, you can use for which direction that you use the positive or the negative sign. Doesn't really matter. Okay, so now it should be clear why velocity is a vector and why it can have a positive or a negative sign. So now when we insert that into our momentum equation, mass, which is a scalar, which is always a positive, so we have positive mass, and we can have positive velocity or negative velocity. So we have positive mass times positive velocity, that gives you a positive outcome. But we can also have positive mass times negative velocity, and that will give you a negative outcome. So this means that also momentum is a vector because momentum can have either a positive or a negative outcome. On the other hand, for kinetic energy, where we have mv squared, this means that we can have a positive mass times positive velocity squared, or we can have positive mass times negative velocity squared, right? Now, what do we know? So positive times positive equals positive. Negative times negative, that also equals positive. Negative times negative equals positive. We know that. So this means that it doesn't matter in which direction something is going, the outcome will always be positive, right? So this means that it's a scalar. Kinetic energy is a scalar. And that's why this is a simple mathematical reason. Because when you square a positive number, and when you square a negative number, they always end up being positive. So it's always positive. That's why kinetic energy is not a vector, but it is actually a scalar. Right? That's it.